Hey everyone, Morgan here. So what we're doing is looking at what is called reaction prediction today. And reaction prediction can be a very tricky thing, okay? Figuring out what the products are of a reactant when you haven't been told what they are. So what we're going to do is break them down into some classes, okay? We will classify them, look for similar types of reactions, okay? And see how they behave that way. The first class of reactions is called a combination, or some people use the word synthesis. Now that's when you have two things, two reactants, A and B. They might be elements on their own, they might be compounds that come together and form AB. Okay, they combine, hence the word combination. Now there are a few possibilities here. I'm going to show you metal oxides, which is something like Na2O, that'll react with water, and that'll form NaOH. And to balance it, we have to put a 2 there. So anytime you have a metal oxide, sodium, aluminum, calcium, etc., reacting with water, it can form a base. Okay? Now, non-metal oxides are the opposite of metal oxides. So let's look at something like SO2. Can react with water, and the opposite of a base is an acid. So this forms H2SO3. Now, we use a fancy word here, ternary. That just means there are 3 parts to this acid, 3 elements: hydrogen, sulfur, oxygen. Now, lots of elements, almost the whole table, can react with oxygen. P4 plus O2 to give me P2O5. That's just one example. Okay? There are many, many others. Okay? And metals can combine with nonmetals. They form salts. So sodium can react with chlorine and form sodium chloride. We put a 2 there, we put a 2 there to balance it. All right, so that's a combination. The opposite of combination would be decomposition, where AB is going to break down into A plus B. So metallic carbonates, something like CaCO3, can break down into CaO plus CO2. Metallic hydroxides like Mg, OH sub 2 can break down into MgO and H2O. And you'll notice that this one is pretty much the same. Okay, they're just going opposite directions of each other. Metallic chlorates like KClO3 can break down to form KCl and O2. We put a 2 there, a 2 there, and a 3 there. Okay? And then some acids like H2CO3 can break down to form H2O and CO2, which would pretty much be the opposite of that one up there that we already looked at, the combination. All right, so those are your decompositions from page 4. When we go to page 5, there are going to be a few more decompositions for us to look at here. Oxides, when heated, can decompose. So, let's go with a nice dangerous one, HgO, mercury oxide. I remember having to do that in a high school lab. We actually made mercury out of that. Looked kind of cool, but pretty toxic. Okay, actually, I'm sorry, no. Balance it, we're going to put a 2 there. Okay. Electricity. Electrolysis. This is something that I'd be showing you right now in the room. Have a big device to do this. You run an electric current through water. you get hydrogen and oxygen gas forming. Okay? Ammonium salts, like ammonium chloride, can break down and make ammonia and HCl. All right, now, that's all your decompositions. We're going to move on to what we call the single replacement. What's a single replacement? Well, metal replaces metal. So you have something like a metal, A, reacts with a compound which is Bc, and that gives you B and AC. It's the metal replacing the metal. The metal always comes first in the formula. So what is this like? Well, this is a guy and a girl walking down the beach, holding hands, and up walks the best looking guy that girl has ever seen in her life. What happens? This guy, boom, he gets kicked out and he has been replaced with that guy. Okay? Now for a non-metal, something similar can happen. Let's assume this time that our non-metal is A plus BC. What's going to happen is we're going to get C plus BA. Okay? So this is the same idea, a guy and a girl walking down the beach together, but a prettier girl comes along, and boom, this one gets kicked out, and that one is now paired up. Not a fun situation. So, realize that we're not talking about guys and girls, we're talking about elements. Sodium is an active metal. It can react with water. And I'm going to write water as HOH, because H is the positive part, what we'd be referring to as the guy, and OH is the negative part, what we'd be referring to as the girl. Non-metal, metal. Okay. The sodium kicks out the hydrogen, it forms NaOH and H2. To balance it, we put a 2 there, a 2 there, and a 2 there. So you take a metal, like zinc, let it react with an acid, like HCl. It kicks out the hydrogen, becomes H2, and we get ZnCl2. Balance it with a 2 there. Now, I'm betting some of you are wondering about that diatomic hydrogen here. Don't forget that really silly word we had, Hofbrinkel. Those are the elements that, when they are on their own, exist as diatomics. So a metal can actually replace a less active metal. And a halogen can replace any halogen beneath it in the periodic table. Put a 2 there and a 2 there. Okay. Now, which metal or which non-metal is going to replace the other one? This is called an activity series. The more active is the one that does the replacing. All right. Let's go on to the next page. Double replacement. This is like a square dance. AB plus CD, and we switch partners. A is now hooked up with D, and C is now hooked up with B. Guy 1, girl 1. Guy 2, girl 2. They switch partners, so guy 1 is dancing with girl 2, but guy 2 is dancing with girl 1. So you can see this in something like NaOH plus HCl to give us H2O and NaCl. We can also see it with what's called a precipitate, AgNO3 plus KCl gives us AgCl plus KNO3. I'm going to put a big star here. We're going to spend a lot of time, a few days, working on precipitate reactions like that. The AgCl, it turns out what becomes the solid. A metal oxide may react with an acid. So something like calcium oxide plus HCl to give us CaCl2 plus H2O. We need a 2 in front to balance that. We can even have some very complicated ones. NH4 sub 2, SO4 reacts with CaOH sub 2, and what we get are 2 NH3s, 2 H2Os, and a CaSO4. Sometimes they are just a little bit complicated. Now, combustion. Combustion is the adding of oxygen to something, burning it. We know that we need oxygen in the atmosphere to have a fire. So hydrocarbons like CH4 can react with O2 and form CO2 and H2O. We can put a 2 there, we can put a 2 there. Metals can burn. This happens in fireworks, like magnesium. Magnesium is also in road flares. We get MgO, 2 and 2. Non-metals, like sulfur, can react with oxygen and form SO2. Those are all burning. Those are all combustion-style reactions. Okay, also, let's not forget exothermic releases heat, and many of these release heat, like the combustions. Endothermic absorbs heat. And that happens with a lot of those also. Okay, folks, that is page 4 through 6 on the outline. Hope you're having a good day. This is Morgan signing off.